experiment to find the Young modulus of metallic wire. Experiment এটা হচ্ছে finding Young modulus All right, so I screen it. I'll take 5 minutes. It's not a very elaborate thing, so I should recover for the verbal. So can you remind me what's the formula for Young modulus? Right, so E equals to stress by strain, right? Now, if I want to find the Young modulus of a wire, I need to find stress and strain. Stress and strain has their own formula as well, right? So can you tell me what would that be equal to? Like, what is stress equal to? Force by what area? Right, okay. And divided by the strain. So what's strain? What length? Right. So এটা যখন তোমার definition চাবে বা equation চাবে, make sure you write that. Okay, don't just say length, don't just say area, cross-sectional area, total length or original length. Okay. So if I want to find Young modulus, these are the quantities that I need. I'll simplify this further. So F divided by A times L divided by E. So এটা করলে আমরা কিন্তু Young modulus পাবো, right? Now we want to do an experiment. An experiment মধ্যে we need to find force, area, length, and extension, and we'll get our answer, right? So how do we do this? So there are two options out there. একটা হচ্ছে you take your wire and you hang it from a height and put mass here, and you find the force. So force would be what of this mass? Force that would be what of the mass? Weight, right? So W equals to mg. I will find what from this wire to find extension, the change. So ধরো এই পয়েন্টটা কত extend হচ্ছে, we find that this is the extension. So I have my extension here. I can also find what here? The original length, right? And আর কি দরকার আমার এই wire হচ্ছে cross sectional area. So these are the things that I need. Unfortunately, this process that we're going to do right now is actually not the best solution out there. And এটা হচ্ছে because of something called term নাই just বলার জন্য, it's called edge dislocation. এটা মানে কি বলি? So what happens is if you take a wire and you hang the wire and put a mass there, right, weight, and you'll notice that the wire stretches, right? But we find that if you keep the mass hanging there for long enough, right, overnight, let's say, the wire just stretch হয়ে যাচ্ছে. Have I changed the force? No, but you'll notice that the wire keeps stretching. Why does that happen? So when you hang a wire and you apply a force, it extends right away. But there are some bonds that over time, if you give them enough time, right, they'll start to snap. And those bonds will start to break slowly. And you'll notice one by one, those bonds are breaking. So over time, এটা বেড়ে যায়. এই process থেকে বলা হয় creeping. Do you know what creepers are? Slowly go towards. Oh no, I was completely অন্য জিনিস বুঝানোর চেষ্টা করছিলাম. Anyways, creepers হচ্ছে plants that grow very slowly. যে তোমার হচ্ছে আস্তে আস্তে হচ্ছে ভাইনের মতন উঠে উঠে পড়ে যায়. That's what I was going for. Anyways, so yeah, it grows overnight. Okay, the point I'm trying to make is overnight কি হবে, এটা হচ্ছে grow করবে, creep করবে, and then change হয়ে যাবে, which means this length is not the original length, right? So এখন এটার জন্য solution আছে. একটা solutionটা হচ্ছে something we do in এটা জানি biologyতে বেশি করা হয়. It's called a control. So what we do is we place a wire on the side with this mass, right? And we see what happens to this mass originally. And যেটা করি আমরা হচ্ছে overnight হচ্ছে রাখবো, একটাতে mass রাখবো, একটাতে mass রাখবো না. and we'll try to compare what happened. That's the correct way of doing it. But you know what happened over the years? They got rid of this, and we don't have this method at all. I'm showing this why because there are some drawbacks like okay. So drawback number one, the wire increase starts to change length overnight, which is why you never get the actual value. Second thing is you need to use a very long wire. Now, very long wire. So the wire is the size of the front, right? So if they practically all basically hanging behind, right? There's not space here. Like in most that do is somewhere near the wire, and then they put your mass there, right? So what you do is basically place flat surface, and open it, taking it out twist and flush with the right version or the acceptable version. This is you take a bench. And I think the practical is a practical question where you do parking, whatever possible. Otherwise, no. 10,000 newtons or like 1,000 newtons is a lot. It's almost 1,000 newtons, right? So করা যায় না version. So you put your mass here, and let's see how many of the formal values here. So the force will come from where? The weight. So the weight of this mass provides the what on the wire? Force, right? So force is the weight of this mass. So a weight যেটা apply করা হবে, mg will act down here. Do you remember that it acts everywhere on the string like that? The নিচে দিকে যে tensionটা থাকে, that's the force everywhere on the string. We did some questions like this, but the mass ছেড়ে দেওয়া হয়, পড়ে যায়, you had to find acceleration. So there's tension in this wire, okay? So once you take the tension and you want to find extension. So extension ta ei jagay hobe. Like the extension takes place here. But that's what the problem is. The extension is extremely small. কারণ আমরা খুব small একটা mass নিয়ে কাজ করি ল্যাবের মধ্যে. So if your extension is very small, can you suggest a device that would be suitable for an extension that's like 1 millimeter? Meter rule problem হবে কারণ meter rule এর division is 1 millimeter. So if you're using a meter rule, you'll notice that it's stuck between the two divisions. So can you tell me a suitable instrument to find this? Vernier caliper. So if you use a vernier caliper precision got to 0.005, right? Centimeters, millimeters, 0.05. So if I use a vernier caliper here, I do get a good reading. But the problem is, vernier caliper it has this, jaw. And you need to place it somewhere and find the change, right? Which is very difficult here because you can't really place it there. So they come up with the solution. It's called a move-in vernier caliper. Move-in vernier caliper have you seen those sliders they use in hospitals for finding weight? Weight scale থাকে না একটা বুঝছো কোন type of weight machine I'm talking about? You stand on it, এটা এরকম tilt হয়ে যায়. They have this slider, they move around and it balances. Have you seen? No, it's called a beam balance. Beam balance ওরকম থাকে আচ্ছা so জিনিসটা কি হয় they have the slider এরকম থাকে and when somebody stands on it it tilts, right? And there's this thing on the top যেটা মুভ করা যায় ওরা এটাকে মুভ করে ব্যালেন্স করে and যখন ব্যালেন্স হয় যে জায়গায় ব্যালেন্সটা হয় that is your mass. Okay, it's basically using moments. So ওই স্লাইডারের মতো এখানে একটা ভার্নিয়ার ক্যালিপার পাওয়া যায় এই যে ভার্নিয়ার ক্যালিপারটা উপরে দেখতেছো it's basically the small scale of the vernier caliper. Remember the vernier caliper had small scale, main scale, right? এরকম small scale থাকে আর এখানে একটা স্লাইডার থাকে ওই স্লাইডারটা হচ্ছে মুভ করে you can find the value. So does it use the formula that we normally use? No, it's a little different, the device. Okay, so এরকম হচ্ছে ডিভাইসটা থাকে এখানে একটা মার্কারের মতন থাকে ওটাতে তুমি হচ্ছে এটাকে স্লাইড করতে পারবে. So what you do is you just move it around. Do you need to know this in details? Absolutely not. All you need to know is that there's a vernier scale used here. Okay, so এই vernier scaleটা এখানে প্লেস করলে এক্সটেনশন কেমনে বের করব? So যেটা ওরা করে is that they put a tape on this wire. এই ওয়্যারের সাথে একটা টেপ কানেক্ট করে টেপটা যখন মুভ করবে what does that show? That the wire is what? Extended, right? So টেপটা কিন্তু এদিকে মুভ করবে. So my question for you, okay, and this is a very important question. This wire that you're seeing right now, this entire wire, right? Is the one I'm highlighting in blue. Etar length হচ্ছে L. The length of this wire is L, okay? My question for you is, if my extension here is X, what is the original length of the wire? I will repeat for you, that change that you see at the top, that's the extension. The tape moved that much. So that's my extension. What is strain? Extension by original length, right? So what is the original length here? Is it L Is it L মানে বুঝছো কোনটা? L মানে হচ্ছে the entirety of the wire. From where? From here all the way down there. That's the L, right? Is that the length, or is the length from this point till the pulley? That's the pulley, right? Or is it from here till the tape? So what is the original length here? It's an MCQ you get. এই পুরো ওয়ারটা কি অরিজিনাল লেন্থ হবে, নাকি ওই ফিক্স পয়েন্ট থেকে পুলি পর্যন্ত অরিজিনাল লেন্থ কনসিডার করব, অর ডু আই কনসিডার ইট বিফোর দ্য টেপ, দি এন্টার বিফোর দ্য টেপ? Questionটা কি বুঝছো? I'll give you the answer, but do you understand the question? The question is, what's the original length? I know it might feel like original length মানে তো original length. This is basically the whole wire. X হচ্ছে the extension that takes place at the top. আচ্ছা, এই পার্টটা টেপটা যখন এই জায়গায় চলে আসবে, L minus X, huh? Okay, I'll tell you what the correct answer is. The correct answer is the length before X. So the reason behind that is, it's quite interesting. I'll show you how it is done. If you take a spring, right, and you apply a force here, I mean, a stretch করতে see, I don't know if you can notice this, but stretcher spring এর যে গ্যাপ গুলো ওরা সেম না, and যখন এটা করি spring এর গ্যাপ গুলো different হয়. And can you tell me where is the force the greatest? মানে কোন জায়গায় হচ্ছে force এর সাথে বেশি অ্যাক্ট করতেছে? I know you might feel like it's same everywhere, which is partly true. Acha, so where is the extension the greatest, or the force the greatest? So what happens is, I'm going to if I consider only this much of the spring, right? I mean, force likely it took stretch হয়, R2 যদি add করি R2 বেশি stretch হয়, R2 add করলে R2 বেশি stretch হয়. So you'll find that the extension that happens is for the material behind that extension point. What I mean is that I'm যদি পুরো স্কেলটাকে নেই, right, and I stretch the scale from this edge, right? The scale has all these materials that will stretch. But if I cut the scale into half and I now try to stretch with the same force, right? Don't I have half the material available? So do you think it will stretch as much or less? Less, right? And if I take it like this point, like, you know, that small length there, and I apply the same force as before, will it stretch as same as before or much lower? Much lower, extension যখন হয়, it's because of the materials behind the point where you apply force getting deformed, not in the front. এখানে যদি extend হয়েও থাকে, would that reflect here? No, aren't those materials after that? So এখানে যেটা হচ্ছে, yes, the force is acting here, right? But problemটা কি হচ্ছে, এইখানে যে force act করতেছে, which is the same as there, right? But this part will only extend because of the amount of material that's behind it. And that's the reason why আমরা আমাদের ফর্মুলাতে extension use করি না, আমরা use করি কি extension by the original length, because it turns out every point on your wire extends by the same ratio. মানে আমার 1 centimeter যদি হয়, it'll extend 1 millimeter. 2 centimeter যদি wire হতো, it will extend how much? 2 millimeter. You get what I'm trying to say? 3 হলে 3 millimeter. No, what's the reason behind it? It's the same reason, surprisingly, as we saw with our series and parallel springs. So, you guys remember the series and parallel analogy I showed you guys? Don't worry. A series wire যেটা হয়, so think of this as a small piece of wire, okay? And think of this as a small piece of wire as well. I fuse the two together, so it's now one piece of wire like that, right? When I apply force and stretch them, aren't they both stretching? So isn't the extension going to double up? Because এটা একটা stretch করে, এটা একটা stretch করে. But when I take the wire individually, এটাও stretch করবে same force in there. But is it the same extension or half the extension? Half, because what happened to the length of wire that I'm investigating? Smaller. So আমি যদি এরকম করে thousands of these springs attached to it, doesn't that look like a wire itself, right? So wouldn't it mean that each section extends by a certain amount, right? Wouldn't that all add up to the total extension? So এখানে যেটা হচ্ছে, think of this as one spring. This is one spring, and then another spring here, and you're applying a force here, you're applying a force here. So এই পার্টটা হচ্ছে একটু extend করবে, let's say x. এই পার্টটাও একটু extend করবে, let's say x. What is my total extension going to be? 2x, right? So point I'm trying to make is that whatever extension happens at a given point on your wire is because of the materials before it, not after it. So which only means that my extension is due to this length here, not the whole wire. And that's the original length for this scenario, because they cannot tape কোথায় মাঝখানে. If my tape was at the end, right, what would the original length be? The entire wire, okay? So yeah, that's my original length here, L. So we have L, we have extension, force চলে আসছে, এখন একটাই বাকি, cross sectional area. Can you tell me what instrument do we use for cross sectional area? Micrometer screw gauge. How do you find the area of a wire, cross sectional area? Which instrument? So you want to calculate it. Find the circumference. আচ্ছা, তোমরা কি বুঝছো আমার কোয়েশ্চেন যারা অ্যানসার করতেছো না? My question is, what instrument helps you find the cross sectional area of a wire? এই যে একটা wire যদি নেই, আমার এখানে cross sectional area is that part, right? I want to find the area of that part. What instrument gives me the area of that part? Micrometer? Diameter? Achha, okay. So the correct answer is you can't find the area using an instrument. There's no instrument out there that gives you what? Area. What do instruments give us? Dimensions. You can get length, you can get breadth, you can get height, right? And what do you use that for? Calculating area. So the MCQ ashe how to find the cross-sectional area of a wire, right? And we can micrometer screw gauge thakbe, and that's not the answer. So can we measure area or do we calculate area? Right, okay, fine. So এটা calculate করার জন্য what we do first is we find diameter of the wire, and for diameter what we use here, micrometer screw gauge, and then diameter থেকে area বের করার জন্য কি করতে হবে? Pi d/2 whole square. Okay, so yeah, that is the experiment. এখন I'll give you the process and everything, but there's an interesting side note to add here. প্রবলেমটা হচ্ছে এই ওয়্যার গুলো যখন আমরা কাজ করি এগুলা নিয়ে, right? The extension is so small, even a vernier caliper sometimes suffers. মানে they're not that substantial. Buchho what I'm trying to say? Because it's a wire and the stress needed is like 10 gigapascal. A 10 gigapascal provide করার জন্য we don't really have the mass. So এটা ল্যাবে করতে গেলে it's a little difficult because if তুমি force দিয়ে যাচ্ছ, what is the wire not doing? Stretching. Why not, right? So my question for you, and see if you can answer this. How can I make the wire extend a lot for a very small amount of force? Make it thinner. Question কি বুঝছো I'm trying to say? মানে আমি হচ্ছে ওই ল্যাবে 100 নিউটন দেওয়া যায় easily, 10 kgs, right? I want it to stretch a lot for that 10 kgs. How can I maximize the extension? A lot of wire. Can I use a longer wire instead? That's okay. We'll use a longer wire. You can use multiple wires as well, but longer wire is good. Okay, fine. Anything else? Right. So look at this. Okay. So the question they ask you is, why do we need a long and thin wire for a good extension? So economic keyboard, I'll take the extension and bring it on this side. I'll make the extension the subject. So if I want maximize extension, can you tell me, and the force key রাখার চেষ্টা করব? Same, right? And young modulus key থাকবে constant. So there are two things that I can work around with, right? What are those? Yeah, so can you tell me what kind of a length will give me more extension? Yeah, more length. So I need what kind of a wire? Long wire. And what kind of cross-sectional area will give me higher extension? Smaller one, right? So cross-sectional area মানে হচ্ছে thinner wire. And we find that if you use a long and thin wire, in some cases, right, you can achieve like centimeters of extension, which is like very good, okay, with a very small amount of force. What did you use in that scenario? A very long wire and a very thin wire, and that's why long wire the best way bench jodi kora jay, hang korte gele problem hoy. Okay, that's why we use the bench version. Also bench version e eta hoy na creeping, because you're not actually applying high force on the whole wire. It's just a small segment. Okay, so yeah, there you go. This is the experiment. Side note as add kore dicchi, but that's it. We're done with the materials. If you have any questions, you can let me know. Certainly, yeah. মানে একটা point of view, you're right. Before it breaks, but উড়ে যেটা হয় যে দেখা যায় তুমি ফোর্স দিয়ে যাচ্ছ, এক্সটেন্ড হচ্ছে না, সাডেনলি কি করে ভেঙে যায়। দ্যাটস হোয়াই ইটস কনসিডার্ড টু বি ওয়াট। দ্যাটস হোয়াট বিটল মিনস। সরি? For a higher force and a thicker wire. Yeah, because if your force increases 2 times and your area also increases 2 times, you'll find that it doesn't really change the extension. Yeah. Huh? All levels are 2. 1. But all are math. All right, so copy this quickly. This is তোমাদের হচ্ছে এই নিচের পার্টটা very important. Yes. All levels are not 99. Biology was, I remember, they're all 90 up, but I remember 94 maybe. Lowest was chemistry or English, one of these. All right, so yeah, copy this quickly and then we will start the waves. No, I. I think it should have been 2. I mean, I never had plans for chemistry anyway, so having chemistry was like a burden. And also, universities don't really need 3. I mean, if you're going to study computer science, right? What are you going to do with biology? Electrical engineering. So chemistry had 0 use, like or negative use. If I didn't have chemistry, maybe my life would have been easier. So it's a negative use. Huh? Allow for it. It's a false condition by schools that you should have 3 subjects. It's no need. Yeah. Yeah. It should be optional. You just that's it. Countries. I don't remember. It's like 20 years back. I know that it was lowest, and it was more than 90. More than 90. Yeah. It's something nice to say. School all over support. University না কোন ইউনিভার্সিটিতে ওরা ওই ওয়ার্ল্ড হাইস্ট টেকনোলজি করে না I mean, if you have like a full resume of multi faceted extra curriculum, they will consider. But it just একটা world has আর এখন তো এটা আরো উইক হয়ে গেছে, নাও দে প্রোভাইড কান্ট্রি হাইস্ট, মানে দেখা যায় নেক্সট উইক আসবে উত্তরা ধানমন্ডি হাইস্ট, এনিওয়ে টু ব্রিং পিপল অন স্টেজ। এগুলা জাস্ট মার্কেটেড আর কিছু না এখন। এটা হয়েছিল বিকজ there was a year কেউ বাংলাদেশ থেকে কোনো কিছু ওয়ার্ল্ড হ্যাজ পায় নাই, so they basically had to have like a empty segment daily star awards there, but they decided in a country has the day আমরা locally daily star কোনটা খালি পেপার। হ্যাঁ না, আমাদের টাইমে ফোন দিত, আস্তে আস্তে কমাই দিচ্ছে, এখন স্টুডেন্ট হয়ে গেছে না, তো আই ডোন্ট থিংক ইভেন কিছু দেয় এখন। ও না, আমাদের টাইমে ফোন দিত, গুডি ব্যাগ ছিল, পেন দিছিল একটা ফ্যান্সি, ফালতু ফোন একটা। তখন একটা ব্র্যান্ড ছিল সিটি স্যার, সিম টিমও ইউজ করা যায় না, ইটস লাইক দ্য ওয়ার্স্ট ফোন এভার। উঠে গেছে কোম্পানি নাই। না না, they give it to students. হয়ে গেলে বলো, just the highlighted part is important, so if you're done with that I'll start waves. Before 18, isn't your school exam going on? When does it end? Oh, this Saturday. I will include some parts of waves and deformation for sure, so first week of December maybe. Master Money physics is over this Friday. Our GPS is শেষ. How was it? Was it like structured and MCQ? Did you have practicals as well? Master Money full electricity. So full syllabus. আর 1 month আগে যদি শেষ করে দিতে পারতো, অক্টোবরে দিয়ে দিতে পারতাম। আর 7 month বসে বসে বলতে হবে এখন। Oh, so the two clamp stands fell over, but there was no G clamp to. I think the forces were too large, maybe. That's a lot. But was that in the question? Uh, 0.3 and 0.6 kg. No, so normally the base of the clamp, there are two types. One is like this one. This one is like the worst. এটা তো হচ্ছে otherটা নিচেরটা is like 3 times bigger, very heavy. The base এর জন্য পড়ে যায়। বুঝছি, সিরামিকের মতো। ওটা কেমিস্ট্রি ল্যাবের জন্য। Physics এরটা হচ্ছে is like very thick, very heavy, so it doesn't need a clamp for itself. অনেক heavy থাকে। এগুলো পড়ে যাবে তো থাকতে পারে। এটা দিতে পারবা। One of you use batteries to balance it. That's a good idea. I use batteries. Oh. Wrong size. It's a practical ওরকম worry করা লাগবে না, because eventually if you notice it can make a difference. ওটা যেটা হয়, ওরা যখন রিয়েলাইজ করে যে they didn't give you the right thing, ওদের একটা রিপোর্ট লিখতে হয়। ওই রিপোর্টের মধ্যে ওরা বলে দেয় যে we failed. That's what they do. Questionটা হ্যাঁ। আচ্ছা, okay, let's start. সবাই একটু এখানে কিছু প্র্যাকটিস কোয়েশ্চন আছে। At this moment প্র্যাকটিস কোয়েশ্চনগুলো আমি একটু স্কিপ করে যাচ্ছি because I feel like সিলেবাস থেকে আগায় রাখাটা is more important. এমনিতেও কোয়েশ্চনগুলো eventually পড়তে হবে আমাদের, okay? And honestly speaking, তোমাদের করা দরকার। I mean, class I'll be doing them, but you have to try them on your own at home as well. But yeah, I'll start waves. Waves হচ্ছে একটু, it's not a big chapter, but everything that I'll be teaching you is completely new. So it's not the O-level waves at all, okay? It's a completely different chapter. Page 25 is out too. Right, so this part is the only part that you might find relatable to O-levels. Tachara, whatever we study is very different, okay? So I'm going to heads up the sequence of things we'll be learning. So obviously we have the first part, which is the properties of waves. এখানে হচ্ছে the classic হচ্ছে তোমার একটা ওয়েভের properties গুলো কি কি হয়। So you have like your amplitude, wavelength, time period, those stuff you remember. Then we have the two waves that we need to learn, like O-level theory, transverse wave and longitudinal wave zero properties, like what they are. Achha, these are all O-level stuff. Then we have a formula V equals to F lambda. Do you remember that, the wave speed equation? So that's there. And we also have, এখন এটা আরো details আসবে, and এটা একটু ঝামেলার একটা topic, the working of a CRO, cathode ray oscilloscope. এখান থেকে অনেক কোয়েশ্চেন আসে MCQ তে, okay? And there are some tricky questions out there because ওরা waves গুলো এরকম waves, random shapes দেয়, আচ্ছা? So ওইটাতে স্টুডেন্টদের একটু ঝামেলা হয়। So that's properties of waves. But what's new? I want to tell you কি আসতেছে and কোথায় ফোকাস করতে হবে, okay? So after this we'll start a chapter called Doppler effect. So Doppler effect O-level say extra থাকে তোমাদের নাই। It's an idea of how sound changes if it's moving away from you towards you. Example of Doppler effect তোমাদের O-level ছিল with astrophysics, space physics, the redshift. Do you remember the redshift? So that was only there. So, but the science behind it, it wasn't not there. Like, কেন হয় এটা? So we'll be doing Doppler effect. We'll be doing something new, and this is so far যে question গুলো আসছে খুবই unfortunate যে complicated questions করছে ওরা. So যদি future এই trend follow করে একটু careful থাকতে হবে. It's called polarization. Polarization is basically two filters থাকে. Filters go the wave travel করে, and the wave changes its pattern. And using that, you can manipulate how waves behave, right? So that's something we'll see. Polarization as a topic introduced in course, that's a good thing because it's everywhere. Right now, you're seeing polarization. Every time, every day, you experience polarization. So that's why they introduced it. But question could be complicated for it, okay? So that's another chapter. Then the core of this chapter is called superposition. It's like when two waves, right, they meet and collide and interfere, they lead to different things out there. Constructive, destructive superposition. We can take it, we have this thing called stationary waves. Okay, so stationary waves, it's like how strings produce sound in a guitar, right? Ogla stationary waves. Then we'll do something called, as an experiment, Young's double slit diffraction experiment. So Young modulus, discover course, that person also has another experiment wave called the Young double slit interference experiment. ওইটা শেষ হয়ে যাওয়ার পরে we have that's it, I think. Sorry, diffraction grating. It's like this small piece of glass or to the light jet, and it does like a pattern on the screen. Eগুলা সব মিলে is your wave. Now each of these topics are like a day or two maximum, right? But we have like 5 of these. So our estimate normally হয় around 10 classes lage. Okay, so 10 classes we'll try to wrap it up. I think I already told you I want to wrap it up by December. So December যদি এটা করে ফেলি, we are par, মানে ও যেখানে থাকার কথা. Okay, so let's try. আজকে start করি. Right, so today we'll be looking into the features of a wave. এটার জন্য হচ্ছে কিছু লেখা লাগবে না, just স্ক্রিনে দেখো কি হচ্ছে. So properties of waves and how to describe a wave. So this is entirely O levels. In fact, if you had good memory of your O levels, it's a part of that. But I used to skip it before. I think students, forget the O level stuff. So it has only মনে থাকে না. So I'll just go through it. So first thing first, how do we represent a wave? So wave তো হচ্ছে কি আমাকে বলতে পারবা? Just as I draw, tell me some basic information. What's a wave? That's the shape of a wave. What's a wave?
It's the movement of stuff.
No. Yeah. So wave হচ্ছে a process or medium of transferring energy. Wave কিন্তু energy transfer করে আর কিছু করে না. Okay. So how does it transfer energy? I'll show you with an example here. The path. Oh, no, the process is the wave, not the path. So to screen it, let me show you something here, which is the different types of wave and how energy is actually transferred. It's an important demonstration here to observe. So what we have here is like a wrench, and there are these beads here, and they're connected at the other end. Okay, so আমি যেটা করব, I will move the wrench up and down. As I move the wrench up and down, what is given to the wrench? Energy, right? And that energy transfer হবে সামনে. I'll show you how. Okay, so look at this. Do you see a ring at the other end? A ring to right now is stationary, right? What I'll do is I'll move the wrench up and down, see what happens to the ring. Okay, so if I just move this up and down like that, do you see the ring go up and down as well, right? I'll repeat for you. So what I'll do is slow motion. Okay, so I'll go up and down. Do you see there's something going forwards, and then it reaches the other end, and do you see that the ring goes up and down? Like the ring to upor niche gelo. So what is happening here? Abar hobe dekho. So go forwards, and the ring goes up and down. So what happened was it took the energy from my hand, which I did like that, to the wrench, and what did it do? Transferred the energy forwards, right? But the thing that is used to transfer the energy is vibrations. So wave হচ্ছে transfer of energy by vibrations. Vibrations will either perpendicular to the direction of your wave or parallel to the direction of your wave. Perpendicular hole, we give the wave a name. What do we call it? Transverse wave. Or parallel hole, what do we call it? Longitudinal waves, right? So yeah, the idea is that wave is such a way of transferring energy through means of vibration. আমাদের A levels we have a topic যেটা O levels ছিল বুঝানো হতো না details called electromagnetic waves. Electromagnetic waves also transfer energy, right? Like a light coming to me, but there's no vibration out there. Cannot, because it's in through a vacuum space. So what actually vibrates when an electromagnetic wave is transferred? Turns out electric and magnetic fields oscillate for it, and we field oscillation মধ্যে কি generate করা হয়? Energy. Okay, so the point is you need vibrations. It doesn't need to be of particles. It could be of particles, it could be of field, but you need these oscillations, and that is what transfers the energy. A simple example would be I'm using like a rope play, right? And what I do is I move the rope up and down like that. Can এটা সামনে যায়? So it's like a chain process, okay? When I move the rope up and down, this rope moved up, right? ওটার পাশের পার্টিকেল গুলোকে রোপটা কোথায় নিয়ে যাবে? উপরে। ওইটার পাশের পার্টিকেলটাকে রোপ কোথায় নিয়ে যাবে? উপরে। So it's a sequence of particles going up, and then I bring my hand down, so the rope will pull the particles down. And what does it create in the stream? A vibration and oscillation, and that takes the energy forwards. Okay, so when you drop a rock in the water, you'll find ripples travel forward, right? That ripple that travels is basically the particles taking the energy forward. So that's like the essence of what a wave is. Now, and by the way, these are all level stuff. So I'm going to ask you some questions here, and I want to see if you can answer them. So যে ওয়েভটা এরকম দেখতে called a sinusoidal wave, right? এই যে সাইন গ্রাফের মতন কোসাইন গ্রাফের মতন এই ওয়েভ গুলো usually transverse wave হয়. Okay, so you have this here and it goes there. This is one complete oscillation, act a single wave, right? So I'll put this here and I'll put that. So now I have two waves. Question for you, okay? Can somebody tell me in this particular diagram what is the amplitude? How do I label the amplitude in this diagram? Right, what was it? So define amplitude, O-level question. Amplitude is the right, correct. Amplitude is the maximum displacement of a particle from which position? Rest, okay? So that is your amplitude here. And a niche distance এটা কি same হবে না different হবে? Same, okay? So that is also going to be the same. So yeah, amplitude is the maximum displacement from your rest position. So can you tell me এই diagram যেটা এখন draw করব এখানে amplitudeটা কত? Draw করে নিই। Right, what is the amplitude of this wave? Sorry. Right, what is the amplitude of this wave? এখানে যে ওয়েভটা দেখতেছ এটার amplitude কত? $2.5. কি হবে? Is it 2.5? Is it 14? Is it 9? Is it 5? Yeah, so if you look at this distance here, this gap here, how much is that? 5, right? And amplitude is the maximum displacement from the undisturbed position, right? Undisturbed position for this wave happens to be there. So if you think of that, this height here is your amplitude. And how much is that height compared to the total length? Half, right? So what should that be? 2.5. So why am I showing this example? Because a couple of years there a question asked where the origin is not 0, it's somewhere up. Translation math of graph, basically your graph is translated. Even if your graph is translated, it doesn't really change the wave, it just changes the values out there. When our wave to matite oscillate korteche or upore oscillate korteche, it's the same wave, right? Just the y-axis values are different. So yeah, this is your amplitude. Now another question. I'm going to শেষ করে যাব আজকে, okay? Can you tell me what is this point representing? The point, the red mark there. What is the red mark? What does it represent? wavelength na the কোন red part বুঝছো যে this one. What is this? Sorry. Yes, correct. But how do you represent it? What do you call it? আচ্ছা আমি বলে দেই এটা হচ্ছে as she mentioned the position of the particle এটাকে আমরা ডাকি displacement. It's just the displacement of the particle. Where is it right now? But displacement to একটা wave different জায়গায় হতে পারে, right? So if I told you I have a wave that's currently displacement is 4 centimeters, right? How big do you think is the wave? Waveটার current displacement একটা particle on the wave is 4 centimeters displaced, right? How big is the wave? We can't say. It could be a gigantic wave of 100 meters high and we're just looking at the start, or it could be a wave that's 5 centimeters and you're looking at the almost height, right? So if I want to compare waves, what would be the most reliable value? Yeah, the highest displacement and the greatest displacement, right? And what we call that greatest displacement? Amplitude. That's why we use amplitude. But amplitude at the end of the day is still a what? Displacement. It's just a what displacement? The greatest displacement, okay? So that's amplitude. Can anyone tell me how can I label wavelength here? From where to where? Crest to crest. Or is it the only place or are there other places? Any place, right? Yeah, it's the same wave. So this is my what? Wavelength, right? That is wrong. That's not the answer. This is not wavelength. This is the yes, very good. Why? Yeah, exactly. And I showed this in your O levels. More talking about over there. Our graph to displacement versus what graph? Time, displacement versus time, right? So how do you find distance from a displacement versus time graph? তুমি হচ্ছে এখান থেকে যেটা পাচ্ছো, aren't you getting the value on the x-axis? And what is the x-axis? Time, right? So this gives you what eventually? Time period. That's capital T. Then my question is, how do we find wavelength? Exactly. So there's another graph that we have in our syllabus, যেটা হচ্ছে displacement versus what? Distance, how far it travels, okay? And ওই distance graph এর মধ্যে the same label is now what? Wavelength, okay? And এটা তোমাদের প্রায় আসে, দুইটা mix up করে দেয়, so be aware before you answer. Clear?